So now moving on to the next presentation, probably this is one of the most critical aspect of heterojunction, which is silver paste. So the cost and performance influencer in heterojunction manufacturing. We have Jasmine Chen, who is a director of Organic Research Institute at Fusion, one of the leading paste supplier. And Jasmine is going to talk about optimizing the silver consumption in heterojunction solar cells, which is really the hot topic. Jasmine, the floor is yours.
Hi, thank you for introduction to me. Hello, everyone. My name is Jasmine Chen from Fusion New Materials. Today, I'm very glad to be here and share with you about the story how to optimizing silver consumption in HJT cells. This is the agenda today I will talk about. So firstly, I will share with you about the company introduction very quickly, and then we will move to HJT, silver paste requirement, and roadmap and solution. And finally, we will share with you about the Fusion HJT past so the production offering, and then we will share with you our next generation new product layout. First of all, I will share with you a quick company production introduction. So for our company, we start from a startup, very small company, and experienced a very quick and significant growth to a leading so the position in the marketing area. So it's experienced a lot of the milestone, the key milestone. I will quick go through with you. Company established in 2015 and then have a breakthrough in PERC and start the development of HJT silver paste in 2017. And then in 2019, we have a bulk supplier of PERC TOPCon product. Then a big for the start IPO process and acquisition of Samsung Solar Silver Paste in 2020. And then 2022, we have the IPO in Shanghai and also TOPCon HJT mass production from there. And then now we have annual total shipment over than 2,000 tons and with the market share #1 position. Thank you. Our primary business area is still the PV paste. So we have a sales amount over 150 tons per month, and also with the marketing sales with the #1, and also beyond of this, we have other extend our business area to other areas like EV, automobile, customer electronics, and pen semiconductor. As we all know, so TOPCon still the significant sales in this currently. But what's the reason to impact the HJT the development? I think the first reason is the cost. Currently, the cost for HJT is still higher than TOPCon. So if we can find the solution to reduce cost, increase efficiency, and maintain reliability, and the HJT may have the potential to get the competitive with the TOPCon. So the cell manufacturer now use the narrow from for the cost reduction. So the cell manufacturer use a narrow screen opening and thinner finger to reduce amount of silver. And also they use a faster speed of printing and querying to enhance production. Also, they to provide the high demand to us, and we need to provide the lower and lower silver content to reduce the cost. But even though the cost reduction, but we cannot to compromise the efficiency and performance. So from the efficiency side, we need to get the balance of cost down and efficiency have to be improvement. And so for the performance side, so buck resistance have to be lower than 5 ohm and with a different silver content, and need to close equivalent to the pure silver paste, and also the efficiency of 15% of silver copper paste to be equivalent of pure silver paste, as I said before. And also the reliability need also very strong, very reliable. And for the bus bar, so we need a strong tensile strength higher than 1 Newton for bus bar. And also we need to have the very good chemical and physical stability, and to meet the customer the DH 2000, 3000, the requirement. Also for the to have the good chemical physical stability under UV heat and humidity. For the bus bar, also need to have the good resistance to 200 to 300 degrees C welding and laminating temperature. So for the HJT cost reduction roadmap for bus bar, so we can see from here, we use the bus bar, the numbers is increasing and increasing from 9 to 20 bus bar, and optimize the screen opening from 22 from the opening 50 micrometer to 27 micrometer. This is the screen opening, but from the 2024, we also to develop some new technology, like not only the bus bar uses the pure silver, so the past also we developed silver coated copper bus bar. In nowadays, now we are already so use the 55% the silver content for our customer already mass produced, and they are using in their manufacture line. At the same time, most of the customer already use a new technology of zero BB, that it means without bus bar, and they all go through towards lower cost, wider welding windows, and better reliability. So this is the cost reduction roadmap for finger. That is for lower silver content to reduce the cost. From 2023, we provide from 50% silver coated copper paste, and then to quick decrease the silver content from 40 to 30, they all can use in both SMBB and the 0BB. Also, the served front and rear finger paste. But for recently, we developed a new technology. Only the silver paste, the silver content already decreased 20% silver coated copper paste. But recently, it's only suggested to use in rear finger paste. And we still try our best to try our effort to decrease decrease the silver content to ultra low silver content finger, even pure copper paste, to meet the ultimate need of our customer, a low power module and low cost, the requirement. This slide shows the cost reduction roadmap for thinner finger. So now we still in so from 2022 to 2024, the HJT so the silver consumption still higher than TOPCon. Compare with TOPCon, so the screen opening from 2022 from 22 micrometer to 2024 14 micrometer. So the silver consumption from 21 reduced to 11 milligram per watt, and then still a little higher than TOPCon. But use all the new technology, the screen opening, if decreased to 10, now it's already realizing some customer, they use the steel plate. The opening is only 10, even lower, even narrow than 10, and then uses the 0 BB and 30% of silver coated copper, we can get the 6 milligram per watt, and then now already lower. The silver consult already lower than TOPCon. I hope by next year we can to make into realization. With the narrow screen opening, with the faster and faster printing, so we have a very challenging and problem in the HJT. So the marketing that's the problem and challenging is printing performance. It's very hard to get the very good printing the line, because narrow we need the solution, get the solution to solve the problem. So our solution to solve this problem is improve the capability. So the capability is very important for the very narrow so opening and thinner line. So how we improve the system capability for this approach, we use the optimization of past organic composition. For the composition of HJT silver past, you can see. So the three types of the composition for the formulation. One provided the conductive phase, that is always the silver, the metal, silver or silver coated copper powder. So the second one is a resin. We usually use the epoxy resin, and then the third one is the organic solvent and additive. So if the compatibility is not very well, so the particles will aggregate together and cannot disperse very well in the resin and the system, so that the printing will have a big problem, like the so you can see from the right picture. So we can see the God-shaped defection from this line, and also have the broken grid. Even if the aggregation is very so is a lot of aggregation, even so the screen is possible to the clogging. So that is a very big problem for the manufacturer side. So after we use the optimize of past organic composition, you can see so the lines very straight and very fluent, very good, and already to improve the printability. So how we do it? So the most important is the capability. I say 3 times of capability, and most of all, so organic. So the solvent and the additives is very important, even though the additive is a very small amount in the system, like the dispersion. The dispersion only use the 0.1% in the system, but it's very important to get the high the performance and good capability. So if we combine the particles, combine the good suitable resin and suitable good dispersant and mix them in synergy, so we can get the very, very good printing performance and solve this challenging and problem. That is our solution. Now, our printing windows from the client and customer tests is very good. For now, we already solved this printing problem now. So our solution to enhance efficiency is improve the interface contact. So the interface have two interfaces. One is between particles. The other one is between the particle and the substrate, the cells. So if we can to optimize our organic resin and powder, make this contact very well, and we can enhance efficiency. And another concern is reliability. And after optimize our particles surface coating, and you can see it's a big improvement of the improvement of the copper oxidation and copper reliability. So this is HJT our product offering. So we have a bus bar and a finger. Both of them have the silver and silver coated copper. So we can see so the strength is high for bus bar, and silver content is very low, between the 20 to 60, and super suitable for narrow opening and both SMBB and 0BB. So we already get the balance of cost and efficiency, and from the pure silver to 20 silver, the balance, the cost reduction from 30 and to 50, and still keeps the efficiency loss less than 0.1%. It's very equivalent to pure silver paste. And now I will quick to introduction our next generation of the new products layout. The first one is a non-screen printing. So we use the steel plate and the laser transfer printing series, get a very narrow line of the line wise, it's within 28. And so for the PTP, the laser transfer printing is only 18 to 23, and the efficiency is at least higher than 0.1 than regularly. So the screen traditional, so the printing. This is another new product layout for perovskite cell paste, and also we use the curing temperature is a very low temperature, 120, for 20 minutes, and get the so efficiency less than 0.5 than pure regular pure silver, so the paste. This is another new lay point, is a copper paste, and also from the new technology of sintering copper paste, so it significantly can reduce the contact resistance. Okay, these are our clients, some of our clients. We are ready here to serve our clients.
Okay.
Thank you for your attention. Sorry.
Thank you, Jasmine. I think there was some technical glitch. Yeah, we should try to avoid that. But nevertheless, I think we managed well. So thanks a lot for this very nice insights into the pace. There might be some questions. Even I posted a question, imagining that you would be late. So please answer these questions in the chat window. And then please also stay till the end, enjoy our panel. So that, and then I would like to move to the next presentation.
Thank you.